Hi, today we're going to be walking through the steps on how to program a 3-axis milling part using GibbsCAM. Now, I'm using GibbsCAM version 24, which may have it's the newest release, so it has quite a few new features that we're going to review. So the objective today is not necessarily to show you how to properly process a part, how to use tool selection, cutting parameters, things like that. The idea for today is to walk you through the steps in GibbsCAM on how to program this part, and not only show you the how, but also give you an idea of the why we do things, and some tips and tricks and best practices to get you moving forward on a 3-axis mill. So with this GibbsCAM interface, this is really the basic interface for version 24 for GibbsCAM. I do have some special items up here to the right that I've added. You can customize this interface to look exactly how you want it, to highlight specific tools that you use and de-emphasize tools that you don't use on a daily basis. But this is in general what the generic interface looks like. Now, for me, when I typically start a 3-axis mill part, I come in and the first thing I want to do is set my document control up. Document control is an important place. That's usually your launching point when you start programming. And your document control essentially tells the software what machine you're going to be programming a part for. In this case, I have a machine, an MDD, which is my machine definition document. Not important to know what the acronym is, but you want to select the machine that you're going to be programming for. And ideally, you want to do this right off the bat. This tells the software the kinematics of the machine, whether it has an XYZ axis, whether it has an XZ, a B axis. It tells the machine, tells the software the movements of the actual machine you're going to be programming for. And it is always a best practice to select the machine prior to bringing in geometry or a model. You don't want to switch horses halfway. So ideally you want to start out with the machine that you're going to be programming with. We're not going to worry too much about our stock size and origin right now, or our clearance planes. We'll get into all that as we move forward. Now the material here, we have a pretty good database within the software to generate basic cutting parameters, which is your RPM, your feeds and speeds for particular tools and particular material. Now, if you're using GibbsCAM to generate these cutting parameters, you do want to ensure that you select the right materials and alloys in which you're going to be programming. Now, you will also have to put in the right tool material, number of flutes, coatings, all of that to generate the best feeds and speeds. Now, if you're generating your own feeds and speeds, you don't necessarily need to worry about this too much. You can put in your own cutting parameters as you go along, and GibbsCAM requires a bit less information if you're generating your own cutting parameters. If you're using it to generate cutting parameters for you, you do want to give it the most accurate information possible to get the best starting cutting parameters for your tools and the material that you're choosing. So again, select your machine, and in this case, we're going to be using a 3-axis vertical mill. Now, when you have a 3-axis vertical mill, your master coordinate system is going to be your XY plane. If I go into my view icon here, I can go to isometric view, and you can see that your Z-axis is the perpendicular axis to your coordinate system. Now, when I typically start programming GibbsCAM, I'll open up my Viewport tool here. Now, I like to see it persistent on the screen. However, if you want to save a little bit of real estate, it is located here on the lower left on this coordinate system indicator. If you just travel over it, you'll have all the exact same tools. I like to see it here, although there's no right or wrong. Within this CAD/CAM software, GibbsCAM, there's typically 3 or 4 to half a dozen ways to do everything. So there really is no right or wrong. It's typically what makes you the most efficient and proficient at programming parts. So you may see me doing it in a way which is really just to demonstrate how you should do it or how you could do it. And over time, you'll find more efficient ways to do all of these things, and hopefully you use less clicks to accomplish the same task. So once I have my viewport open, I'll typically use my coordinate system list. I'll keep that open, my workgroup list, and my body bag. I typically like to have all 3 of these windows open. Now, you may see them floating out here in your screen somewhere. I just have them docked to the right side of my screen to keep them persistent in the same place. I like to see them over there. Now, to start off, I've imported a model, and this is the model that we're going to be programming for. You can start with 2D geometry. I'm going to show you some of the advantages of using a solid model now. As you see me manipulating my screen, I'm using a 3D Connection Space Mouse. It's essentially a 3D mouse, and I'm using that with my left hand and my standard mouse in my right hand. But what this allows me to do is manipulate and maneuver the screen quite a bit quicker and more smoothly than you would just by using the cursor, the keyboard hotkeys. Now, as you see, my model came in, and it's very skewed. It's not perpendicular or parallel to any of my coordinate system. Now, you should be prepared that when you are importing models, typically from a customer or your engineering department, the model will come in the orientation in which it was designed. So it's going to come in oriented to how they drew the model, not to how you're used to seeing the model within the CAM software, GibbsCAM. So we will have to do some orientation and relocating of this model, and we're going to walk through those steps. Now, prior to doing that, I'm going to go to my home view here. Home view is very important. Home view shows you a normal or perpendicular view to your current coordinate system, which is our XY plane. Now, if you're not using a 3D mouse, your hotkeys are going to be holding down Control, and using your left mouse will pan your screen around. That's moving from one side, and you can just use your mouse to progressively move it from left to right, up and down to whatever you need. Now your wheel on your mouse is zooming in. Now by default, GibbsCAM is set to zoom to wherever your mouse is. So if I zoom to the coordinate indicator, it'll zoom in and out. Or if I put it on the model, it'll zoom in out to the model. So it zooms in and out to wherever your cursor is located on the screen. And you can reverse the direction in the settings if you'd like to. So it'll zoom opposite to the way it currently is. Now, if you hold down your mouse wheel like a button, you can rotate the orientation of your screen. So you can move and view all different sides of your coordinate system or your part or your model by holding the middle wheel as a button. Now, there are keyboard hotkeys if you'd like as well. So if I hold down Control and use my arrows, I can pan that way incrementally. If I hold down Shift and use my arrows, I can orient my view up and down. Now, if I hold Control and use my plus and minus key on my keyboard, I can zoom in and out that way. So those are the hotkeys in which you would use just your keyboard to manipulate your viewpoint within GibbsCAM. So once we're here, we need to get this model in an orientation that will let us machine it. We're going to do this in two operations. Op 1, we're going to be machining the part in this view. So this will be the top, this pocket will be on the top side of our part. So we need to get it in position. Now, one of the things I'd like to show you first, and I like to go to isometric view. Isometric view gives me a good perspective of my part in relation to my coordinate system. So for me to reset my bearings and figure out how I'm orienting myself and looking at the part in 3D space, I like to go to isometric periodically to make sure I'm orienting correctly. So within this view, we have to think of GibbsCAM in kind of two modes. There's the CAD mode, which is computer-aided design or computer-aided drafting, and CAM mode, computer-aided manufacturing. That's when we're actually creating tools and toolpath to process a part. So when I'm either creating a model, importing a model, orienting a model, that's to me essentially CAD mode. That's where I'm going to use coordinate systems to orient my model and get it facing in the right direction, essentially. So you'll see right now, because I'm in my 3-axis vertical mill MDD or machine definition document, I have a master coordinate system, which is my XY plane, and that's fixed. So if I open my coordinate system palette key here, I get a series of menus, a series of icons that will allow me to change, modify, relocate a coordinate system. Now you see everything is grayed out because we are in our master coordinate system and we can't change that one. Now our coordinate system list here is where we're allowed to create any new coordinate system that we would like. We create coordinate systems here, we modify them here. So one of the first things I like to do when I'm orienting it is I like to create my standard 3 Cartesian coordinate systems, which is going to be my XY plane, my XZ plane, and my YZ plane. So I'm going to create a new coordinate system by clicking here, and you see my coordinate system modification palette becomes active. And I'm going to tell it this new coordinate system is going to be the XZ plane. Now, it's important to note that when you click the new coordinate system button, it creates a clone of the current coordinate system that you're actually in. So I created a new coordinate system, and it's the exact same as my XY plane until I change it. So for this coordinate system, I'm going to also create a new one. So I have 3 coordinate systems here, which are all essentially XY planes. They are all XY planes. I haven't changed them or modified them. So I'm going to go back to my second one that I created, and I'm going to convert it to my XZ plane. And if you slow click on the name, all right, come on, there you go. You can relabel it XZ. So I have my original XY plane, my XZ plane, and then I'm going to go to my third plane, which is still XY, but I'm going to convert this to my YZ plane. So if I slow click on that, I can relabel that one YZ. So now I have all 3 of my base coordinate system planes. Now I wanted to do that to show you how to create new coordinate systems and how to modify coordinate systems, and essentially to show you how to, when you're thinking about orienting your part, thinking about the coordinate system really helps. So for instance, if I go to my home view in my XY plane, if I select this model and I go up here to my Modify tab, I can 2D rotate this, and it will rotate around the perpendicular axis to my XY plane, which is Z. Now if I go to my XZ plane and look at it normally from there, I can rotate, and it'll rotate around the perpendicular axis to this plane, which is Y. So one way you can visualize this is that when you have your coordinate system set up, you can only rotate around the axis that is not listed in the name. So if I were in my YZ plane, I would only be able to rotate around the X axis. And obviously in XY, I can only rotate around the Z axis. So that's one way you can think about it when you're using your coordinate systems and you're orienting your part. Now I'm going to use a quick tool to orient my part first. So you notice when I select my model, it selects the entire model. If I click off in space, it deselects the model. Entire model, deselects the model. Now you have a couple tools up here in your floating palette. This first one is called face selection. And when I use face selection, I can then select individual faces of my model. If I hold down Control, I can select multiple faces. That's my multi-click mode, holding down Control. And again, let go of Control, click off in space, and it deselects those things. So using face selection, I'm going to select the top face of my model. And because I'm in my XY plane, this is the face that I want facing up in Z-axis, or normal to my XY plane. So I'm going to right-click on that and click Align Face to CS. When I do that, it takes that face and makes it perfectly flat to my XY plane. Now you see my part is still skewed, but I'm part of the way there to getting my part oriented. Now I need to put this face and align it with my XZ plane. So I'm going to go to my XZ coordinate system, select this face, right click and align this face to my coordinate system. So there we have it. I'm nicely aligned. My part is straight in the orientation in which I want to machine it. Now my 0, 0 or my origin is not in the place, so I need to position it after I orient it. So we'll work on that next. Now what I did want to show you is that if I were to select this face, which is already oriented properly, and I right click and align face again, it'll just take it perpendicular, or take it 180 degrees from where I wanted it. So to go back, I can align face CS again, and it'll put it back to where I want. So if it doesn't look like it where you want, just right click, align it again, and it'll flip it 180 degrees in relationship to that coordinate system. Okay, so I'm now going to go back into my XY plane, and then I'm going to work on getting it positioned. So now that I'm aligned, I no longer need these coordinate systems. I created those to kind of demonstrate how you would 2D rotate around and how you would align faces to them. But once I'm aligned, I typically can treat these as disposable because they're easy to create, they're easy to get rid of, especially when you're using CAD mode. When you're in CAM mode and you're applying toolpath and work offsets to your part, you do want to keep those because those are being used in CAD mode. Coordinate systems are used in two ways, to orient and also to machine. So for right now, all we have is my XY mode, master or clearance plane. So now you see that my stock is drawn, and the stock typically comes in the shape of the last part you programmed. And that's going to be listed in my document control here. So what I'm going to do is go to Modify and Shrink Wrap. And what that does is essentially acts kind of like Saran Wrap. It takes the stock and it shrinks it to the actual model on the screen or 2D geometry. So now if you go into my document control, all my numbers are changed to reflect the stock in relationship to my XY origin. Now for me, I want to get my XY0 to the upper left corner of the part and on the top face of my part for my Z-axis. So I'm going to go in here and use Modify Move Part Origin. So my Move Part Origin is going to move my origin, my indicator here, to wherever I want to position it. And in this particular case, I want to move it so that my X is along this face. Now, I could go into document control and I could copy and paste these numbers into my origin box, but there's an easier way. You can use the interrogation feature within GibbsCAM to automatically populate these input boxes. So for my X, how far do I want to move it in X? I'm going to hold down Alt and select this face. You see, when I hold down Alt, it turns my cursor into a little square. So you need to make sure you double click in the box, hold down Alt, select this face, and it puts in the X distance for my X. I'll go to Y, rotate my part around, and this will tell me where I want to move my origin in Y. And my Z, I can select the top face. That's where I want to move it in Z. And if I click Do It, my origin is now at the left face, top face, and upper face of my model, and my part is positioned exactly how I want it. And now when I go into my document control, I can see my length in X, my distance in Y, and the thickness of my part in the Z axis. I'm going to change my master clearance plane to 4 inches. I like to have a little bit of a clearance there as the tool comes over, rapids down above my part. Now once I'm in here, assuming that I'm going to be machining this model out of rectangular stock, we need to set up some stock in our document control so we can see it being machined. So if I go to top view here, and I'm going to bring up my document control window, within this I can set up my stock size in relationship to my part. So I want to put an 1/8 inch of stock, 0.125, all the way around my part so we have something to machine off. So my length is 6.5. I'm just going to simply add 0.125 to that. And when I go to the next box, you see it now creates an 1/8 inch of stock on the right side of my part. On my X min, I'm going to put that in negative 0.125. My Y max, 0.125. And my Y min, you can go minus another 0.125. And then you can see I now have an 1/8 inch of stock all the way around my part. Now on the top, I show no material for me to face off. So I can put, say, 50,000 stock. And now you can see it has 50,000 stock that I can machine off on the top of my part. My Z-min, that's reflecting the bottom of my finished part. So let's pretend that we had a piece of stock 1 3/4 of an inch thick, 1.75. We have 50 above our part, on the top of our part, so we can put negative 1.7. That'll give us a bit of material for us to grip on in our vise. So now we have all of our stock set up and we can start machining. Now that we have our part oriented and we have our work offset placed where we want it in the upper left corner of the part, let's think about what tools we're going to create to machine this part. So I'm going to turn on my Tools button and my Cam button. Now, in turning these on, it essentially shows you the workflow in which the parts, the workflow of GibbsCAM. So in the upper left here, which was open when you turned on the tools, this is where you generate your tools. So tool 1, 2, 3, so on and so forth. If you were using a lathe, it would be your turret positions here. So double clicking on one of these empty tiles will give you the menu to create your tools. Now once you create a tool, you'll move down to this lower section of tiles. Now these tiles are where your in-process processes are. So this is where you would start entering whether you want to do a contour or a pocket, a drilling operation. You would put in all of your parameters for depth of cut, all of that information, and your in-work process belongs here. Once you actually create the tool path by applying it to your model or a piece of geometry, your finished operation will end up here on the right-hand side, and this is where you'll eventually end up with a longer list of actual operations. So tool, process, operation over here on the right-hand side. So you have a choice. GibbsCAM, that's one of the things I like about the software, is it gives you many choices on how you like to work. You're not locked in to a certain procedure in how to do this. You can do it in a way that suits the way you like to work. So sometimes I'll create all of my tools right off the bat. I'll create 1 through 20. I'll create all 20 tools with descriptions, corner radiuses, everything I need, and then I'll start creating my processes and operations. Or you can create one tool, bring it down, create a process from that, and create the tools as you go. No right or wrong. It's however you like to work. So in this particular instance, I'm going to double click in this first tile. And you get all the list of tools, broaches, probes, if you have the probing operation for GibbsCAM, that you're going to create. So for this one, I'm going to create a shell mill. I'm going to tell it it's 1 inch diameter. Let's call it a 7/8 shank. Corner radius, let's give it a 30 thousandths corner radius, and maybe a 1/2 inch insert length. Just a very generic tool. Now again, if you're using GibbsCAM to generate your feeds and speeds, your cutting parameters, you would want to put in the proper flute length. But for this case, we're not going to worry about that. Anything that you would put down here in your comment, you could put a description, something like 1 inch for flute insert Endmill. You could even go so far as to put the EDP number or the manufacturer's designation. And if you wanted to take it further, you can put this is in cabinet 2, drawer 6. All of this information will be saved in GibbsCAM, and it'll actually output into the G code, so your operators out on the floor will be able to see these comments, information about the tool in the actual program. So this is a very useful box if you want to go ahead and detail out each of your tools. So I have my tool created. Now, you have an option. You can double click in your process box and select the process. So for this one, I'm going to be doing a roughing process. So a roughing is anywhere where you're roughing out an area, not a single contour like a finished pass, but if you're doing a pocket or if you're doing a facing pass, it's going to be in your roughing tile. And then once you go in your roughing tile, it's going to let you select any tool that you have created that's available to do that process. So then I can select my tool. Now that's one way you can do it. Or you can take your tool and just drag it down and drop it onto that box. Then it will limit you to only the processes that will work with the tool. No right or wrong, however you'd like to do it. They both get you to the same place. So I'm going to select my roughing operation. Now this is a roughing operation process. Now the first thing you want to do is go to this drop down. If you're going to be doing an offset, which is typically a pocket, a zigzag operation, or face milling. And because we're face milling, we're going to select this process. Now from here you put in your cutting parameters, which we're not necessarily going to worry about. And your cut width is going to be important. This is your radial depth of cut, how much your tool steps over from one pass to another. And it typically defaults to somewhere around 50% of the effective diameter of the face of the tool. So we have corner radiuses, so that's why it's a little bit less here. Z-stock, do I want to leave any face on the top of my part, or any material on the top of my part for a subsequent finish pass? No, I don't think so. This stock and shape button, this tells me, am I going to designate my cutting area by the stock, which I have designated within document control, or do I have a 2D shape that I want to select and have it machine? I'm going to use the stock for my document control. You have a couple different methods here. You have a couple of different options down here. You have start, corner, finish, cut. If you're not necessarily sure exactly how you want to process this cut, this is the great one of the great things that I like about GibbsCAM. It's a very visual software because we use tiles. We don't use a lot of text menus for selecting options. So I like to tell it that as soon as you have a green checkbox, you're ready to generate a toolpath or attempt to generate a toolpath. So I like to give it the minimum amount of information possible, see some toolpath on the screen, and then quickly make whatever changes I deem necessary from that toolpath. You don't have to populate 20 or 30 different options exactly right to get toolpath. It's very easy to start generating toolpath. Now over here on the right hand side, I have my Z-axis approach, and we'll give it a little safety margin. We're going to wrap it down to 1/4 inch above the top of our part and retract to 1/4 inch above my part. Now this is telling me where the top of my cut is. This isn't asking for the top of the part despite this little line. It's asking for the top of the cut. And we have 50 thousandths of material on the top of our part. Now where are we going to finish machining? We want to machine this down to Z0, which would be the top face of our finished part. Our Z step is we required numerous depths of cut. If this was a harder material, if we were facing off a lot thicker piece of material, we could put in a Z step there for duplicate many depths of cut. In this instance, we only want one depth of cut. So I have everything I need. There's a green checkbox here. There's a green checkbox here. And if I right click, there's actually another one. So all three of those do the same thing. It lets the software is letting it know it has enough information to attempt to create a toolpath. So I'm just going to click on that checkbox. And you see your toolpath in red. Now, it's important to note that the toolpath represents the tip and center of the tool, not where the periphery of the tool is. So you'll see we have this solid grayish line here, and that's a feed move. That's your entry feed. Your red is your contour feed. So this would be 10 inches a minute here, and the red would be, let's change it to 25 inches a minute. And then at the end of the cut is a dotted line, and that represents the rapid move to 1/4 inch above your part. So if I close this out, I can then go to my OpSim, and below this is a drop down. You want to, when you're starting out, you definitely want to use OpSim. None of these other sim modes are going to give you the representation that you want right now better than OpSim. So if I click on OpSim, it renders this blue piece of stock, and this blue piece of stock is the same size as what you have in your document control stock. Now you have a slider down here. It goes from 0 to 100. So if I put this about 1/3 of the way, around 30-35%, and I click play, it shows that tool come in and machine the top of my part. And the cut face is what's in yellow. Now it's yellow because this is the tool I have highlighted. If I were to deselect that, rewind, and play, it shows it as gray. It shows the tool, shows the cut surface yellow, whatever operation you have highlighted in yellow. Now, whenever you want to watch it again, it's at the end of the program. You hit rewind, and you could hit play. You can slow it down. You can speed it up. If I rewind, you can single step through. So you can see your movements step by step through your process. Now, one of the things I do notice is that when I render my cut, I'm conventional milling. I want to be climb milling, so I know I need to go the other direction. So if I turn on my OpSim, double click on my process, and go back into it, double click it on the left, the operation over here just wakes it up on the left, and on the left is where you open it up to make changes. So I'm starting at the X plus and Y plus side. So to start climb milling, I would want to start on the X minus side. So if I select the X minus button and redo, I am now climb milling and spiraling into my face. Now I have a zigzag process that I could use, a back and forth, but spiraling in, that'll work for me right now. So now if I run my OpSim, I can slow it down and watch my tool, and I'm climb milling the entire way in to facing my part. All right, I'm pretty happy with that operation. Now, one of the things I always teach is when you're done with an operation, I click on any empty tile over here on the right to deselect it, and then just hit this clear button on the left. That lets the software know you're totally done with that operation. You're not going to accidentally go in there and make any changes. Now, if I did want to go in and make changes, there's nothing over here on the process side, but I do have my finished operation. Just double click on it. It'll reselect your geometry if you had geometry selected. Go to the coordinate system of whatever coordinate system you're machining in, and it opens up the process over here on the left. So you can go into there and make whatever changes are necessary. So again, deselect on the right, clear on the left when you're done with that process. All right. Now, ensure that periodically you do a save in case you have a network issue, a license issue, a computer issue, you crash, or if you're frequently getting interrupted like we all are out there on the machine shop floor, give yourself a file save. You can go File, Save here, or you can also hit Control S. That saves also. So make sure you periodically save your progress. Now, let's go to the second tool. So the second operation, I have the top faced. I want to rough the outside profile of my part. So I'm going to create a tool. And let's create a Endmill. Now there's two Endmills here, 0.625. We're going to create a 5/8 Endmill. Now there's a rough Endmill and a finish Endmill. They both do the exact same thing. If you select rough Endmill, it will say in your tool comment rough Endmill. And finish Endmill will just say Endmill. So they both work the exact same way. So I'm going to create a 5/8 diameter Endmill with a 0 corner radius. I'm going to give it an 1 3/4 length of cut, length of flute, and a 3.5 inch overall length. All right, you can put a tool comment down there if you'd like. 5/8 inch Endmill, 5 flute, whatever flutes you would like to put in there. So now I have my tool created. Now I don't have any 2D geometry. Now you can create geometry, tool path direct from the model. You can create it from 2D geometry, or you can create it from a tool, what's called the profiler. Now we need something to tell it to cut all the way around the part. So instead of selecting the model, that's a way you can do it, and we're not going to talk about that right now. We're going to kind of stick to the basics here. So there's also a tool right here called the profiler or slice plane. Now if I select that, it superimposes this translucent grid over the active coordinate system. So it's a grid on top of a grid. Now you see there's a light green grid to this translucent layer here. I can actually click on that and drag my profiler up and down through the part. And you can see it gives us geometry that we can select and machine from. You can machine from the profiler outline, this outline in green. You can actually machine from that. With this, that's a little bit more down the road. We're going to stick to creating 2D geometry. So if I drag this translucent grid, you can see it doesn't give us everything we need. In this case, it's only giving us this upper section. If I drag it down to the bottom, it's only giving us this lower section. So I want to find a place right in the middle that it gives me the entire outside of the part. And once I do that, in this green line, I'm going to select it, right-click on it, and extract that as profile. What that does is it converts that green path into actual 2D geometry. So when I turn off my profiler, just select that again, I now have connected geometry all the way around my part. Now this 2D geometry is the outer profile of my part. I'm going to machine that. Now, I don't necessarily care where this is in Z, because the Z depths of my cut are going to be generated in my tool process. Now, if you did want this at a known position, you could go to Modify and Force Depth. And Force Depth is to, say, the top or the bottom of my part. In this case, I'll Force Depth it to Z0. If I click that, it takes that 2D geometry and it impacts it up on the Z0 depth of my model, or the top face of my model. It makes it a little bit neater there. So now that I have 2D geometry, I typically like to break my geometry, and when I say geometry, I mean lines, points, and arcs, and circles. I like to create 2D geometry and separate them or delineate them on different work groups to keep my workspace a little bit less cluttered and more organized. So this work group column here is a list of different layers that you can use to apply different geometry to different places. So you could pull all the holes, slots, pockets, islands, and put it all in one workspace, but it does make your workspace a little bit cluttered. So I like to try to stay as organized as possible. So now that I have this outer profile, I'm going to slow click on Workgroup 1, and I'm going to rename this one and just call it Outer Profile. You can name it whatever you'd like, just as long as you can identify what is on this actual workgroup. So that's going to be my Workgroup 1, and I'm going to keep only my outer workgroup geometry on this workgroup. So now that I have 2D geometry to machine, I'm going to take that tool, that 5/8 tool I created, drag it down, and I'm going to create a contour operation. Now, these are all the information that the software needs to create this outer roughing profile. So I'm not going to necessarily worry about the cutting parameters right now. Entry and exit, I'm going to put 0 there, and we'll talk about those a little bit more later. Stock, this is my stock plus minus an X and Y. This is how much material I want to leave on either my X or Y faces. So let's leave 20 thousandths on each face so that my length is going to be 40 thousandths overall longer, and my width in Y is going to be 40 thousandths longer. That's going to leave 20 thou of material on all my periphery faces. If I wanted to leave stock in my Z-axis, I could put it here. This is a roughing pass. I don't require that. And overlap, we'll talk about here in a second, so I'm going to 0 that out. Spring passes, if you're using this for a finish pass to hold a dimension, reduce tool deflection for wall taper or surface finish, you could put spring passes in here. Right now, I do not require that. So when I get up here, it's asking me my approach and retract. I'm going to keep those the same. And again, this is asking me for the top of my cut. The top of my cut is going to be 0 because I faced off 50 thou. I'm at my 0. Now, how deep do I want to machine? I really don't know how thick my part is. If I had my drawing, I could just reference that. But I can also use my solid model because I have it. So if I double click within that box and I hold down the Alt key again to interrogate this face, I could click that. And it tells me the lowest point, which is this edge, in Z of that face. Now, if I were to select this face over here, it's going to tell me the lowest point on this face, which is this edge, but that's not what we want. We want to profile all the way around the part below the part. So I'm going to select this face. Now, I know I need to cut deeper than that. So I could just simply tell it I want to go minus another 50 thou. And if I hit equals, it calculates that for me. Any box where in GibbsCAM where it's asking for a number, you can actually use that as a calculator. So for this, I'm just going to go negative 1.45, a nice little round number. Now this is where I tell it my successive depth of cut. I don't want to take my Endmill, plow in here, and rough all that material in one depth of cut. But this is asking me my desired depth of cut. And let's say I want to do 200 thousandths, 0.2 depth to cut. It's going to divide that up evenly from the top and bottom of my cut into 8 passes at 0.181. If that's too little, I could put, say, 0.25 in there, and it'll do 6 passes. So you tell it your desired step, and it's going to actually generate into evenly spaced depths of cut. So I'm going to go 0.2. I'm going to turn on retracts, and we'll look at this toolpath. Again, I like to quickly look at my toolpath and then make whatever changes and redo that operation, because within GibbsCAM it's extremely easy to make changes. So as you can see, I do not get a green checkbox. It doesn't have enough information to generate the toolpath. It needs to know what do you want to cut. So it needs us to select the geometry. So I'm going to select this line here, and it gives us these machining markers. And we'll talk about those more just in a second here. So the machining markers are asking you what side of this geometry do you want your tool to be on? The left side, on center, or right side? Obviously, I want to be on the left side. And then this arrow tells us which direction do you want to cut. Do you want to cut to the right, the low in Y minus, or do you want to cut in this direction? So putting the tool on the left side of the geometry and cutting in this direction will give us a climb milling toolpath. We'll worry about these circles and squares in a minute. So if I click do it, I see I have my toolpath going all the way around the part. Now this is once you have your geometry, and again the red toolpath represents the tip of the center of the end mill. Once you have the toolpath, you can start fine-tuning it. So obviously I don't want to come down right on the edge of the part and crash into my material. So I'll put a little bit of a lead in here. So let's say 0.2 straight line and 0.2 radius. Redo that. Now I can see, going to my top view, the tool will come down here, approach 200 thousandths, put a 200 thou radius, and then profile around my part. And when it comes around the other side, it'll do a 200 thou radius and out, and then a 200 thou straight line. And then it will come up and over and down to the next successive depth of cut. If I render this, it looks kind of like this. Now you see jumping up and over, a bit of a waste of cycle time. So this is where I can start modifying it. I don't want to waste that cycle time. So I'll double click on this, open up my process again, and I'll say I do not want retracts. And I'll redo my operation. Implements changes to the current operation. If I were to click do it again, it would create a brand new operation. So I just want to make sure that I just want to make changes to this. So I'm going to click redo. Now you see I have a straight red line from the end of one pass where it feeds over to the other, feeds down, and then into the next cut. So that's another way I could do this. Now, that still might take a little bit longer than I would want to. I can select ramp down and redo, and it will create a helical depth of cut all the way around my part, ramping down the entire way. So I only have one lead in at the top and one lead in at the bottom. And at the bottom it will do a complete flat depth of cut, so it'll make sure it's nice and finished. So this is how you can just continually tweak your process to get you the results that you want. Now if I render this, there's my face pass again. And then there's my continually ramping down outer profile pass. All right. So you can see I put 20 thou worth of stock, so it's 20 thou bigger on each side going all the way around. I could turn on my cutter comp and redo if I want. I have round corners which will automatically break these corners here, and I can put a number in there, say 20 thousandths. Go back in. Redo my operation, and now you have a little bit of a larger corner radius even on these 45-degree corners by putting in a corner break there. Turn that off and it'll get rid of those. Now, if you lose your machining markers, you see I don't have my machining markers, simply go back to the operation on the right and double click it. It'll re-implement your machining markers. Then you can go into your process and remake those changes. So I'm going to deselect round corners, and now I have nice sharp corners on the outside here. All right. Deselect on the right, clear on the left if I'm done with that process. Now, let's say I wanted to do a finish pass on this. I've left 20 thou worth of stock. I don't have to keep reinventing the wheel as far as creating my process and setting up my markers. I could go in here, double click on my roughing operation, and let's say I had a duplicate tool, but it's a finish tool. Let's create an exact same duplicate tool. Maybe it's got an extra flute. I can take that tool and drop it on top of that process, and it automatically changes it to tool 3. I could then go in here and say I wanted to have a little bit more of a faster feed rate. I don't want to leave stock because this is a finish pass, and I want to take it in a single depth of cut. I'm going to turn off retracts, I'm going to turn off ramp down, and maybe I'll add one spring pass to make sure it's nice and straight, the sides, with a great surface finish. My markers are already set, my depth is already set, my cutting parameters I slightly modified, my lead in and lead out is there, Instead of doing redo, which would change my roughing operation, I would simply click do it. And it now creates a finished operation right below my other one. So you can take these operations, you can move them around, you can put spaces in between them. Sometimes if I'm using different tools, I'll keep an empty space in between separate tool operations. Totally up to you. So now that I have that, I can go into my OpSim. And you can see I'm starting to build up a lot of operations, well, a few operations. So if I hit play, I have to start from the beginning and watch the face pass, which I've already said was good. And then I have to watch the outer profile, which I've already said was good. If I want to skip and only see this operation, I can use this box here, which is skip unselected ops. If I select that, it will pre-render all the cuts beforehand and then wait. Now when I click play, it's only going to show me my finish pass, which is op3. So now I've finished the outside of my part. So using skip unselected ops is a way to quickly view and render only the operation that you've done recently, rather than watching it go through the entire part. So I'm going to deselect that and clear here. Now that we have our part faced and the outer profile roughed and finished, we're going to move on and machine this large step here and the two pockets, a closed pocket with an island and an open pocket. So like I said, I'd like to delineate my geometry onto different work groups. So I'm going to start a different work group. I'm going to just simply click new work group, and I'm going to call this one step and pockets. You can rename it whatever you'd like. So you can see I no longer have visibility on my other work group, which is my outer profile. You have two eyeballs here. If I double click on the first eyeball, I can still see my outer geometry, but I can't interact with it. It's gray because that's not the active work group that we're on. If I no longer want to see that, just double click on the eyeball and it goes away. So for my step in my pockets, I need to find the geometry to machine this top step here and then the pockets. Let's worry about the step first. So the only piece of geometry I need to machine this step is this lower edge here, this bottom of this face. So to extract that from the model, I'm going to turn on this second button here. We talked about face selection already, where we can select individual faces of the model. This is edge selection. So if I select that, it highlights all of the edges of my model. So I could select this edge or this one. If I hold down Control, I could select multiple edges, click off and space to deselect. So the only edge that I need is this one here. So I'm going to right click on that and extract that. And it will convert that to 2D geometry. When I turn off my edge selection, I can now see that in yellow and blue. So that's the only piece of geometry I need to machine this step. So in this one, I'm going to use that same 1-inch Endmill. Actually, I'll use a different one. I'll create a larger tool. I'll create a shell mill or an 90-degree insert mill. I'll call it 1.5 inches. We'll give it 1.25 inch shank. We'll say we have 3/4 inch inserts. Oops, 3/5. And we'll also put a 30th corner radius on these as well. So 1.5 inch diameter, 90-degree insert cutter. So now that I have that tool, I'm going to bring it down. I already have my 2D geometry created. And I'm going to cut this as a contour. So I can put my cutting parameters in here. On this particular one, I do not need a lead in and lead out. This is it's just cutting a straight line here. I do not need a spring pass. So it's asking for the top of my cut. The top of my cut, since this is all still solid material, is going to be at Z0. I have no idea where the bottom of this cut is, but I can double click in here and hold down the Alt key. Again, that's to interrogate, and interrogate this top face. And that tells me the depth of this step from Z0. What's my depth of cut? Let's call it again 0.2. 0.2 depth of cut, so it's going to round it to 0.156 and do it in 4 passes. I don't need round corners, I don't need cutter comp, so it doesn't have everything it needs. Again, no green checkbox. It needs for me to select the geometry. So I'm going to select the endpoint of this line and set up my markers. I'm going to select the left side, and this is the correct cutting direction for climb milling. So it has everything it needs, so I'm going to click Do It. So you can see my depth of cut, it retracts, feeds down, and does each successive depth of cut. Now one thing you'll notice is that it's going to be approaching, this is the center line of my tool, and feed down onto the side of my part. I want it to feed out here in space and cut off out into space. So I need to give it some straight line feed in. So I could either do it here, I could give it some lead in that's greater than the radius of my part. So if it's 1.5 inch tool, 3/4 of an inch radius, let's call it 1 inch. If I put 1 inch in here and redo, it will now start off of my part and feed off of my part. So that's a good looking tool path. Now, there's another way you could do it. If I zeroed that out, click redo, these white circle and black circle, I can extend my tool path by simply just clicking on that and dragging it. I can do that on the end and redo, and it will extend the tool path. Now that's a random number because I just clicked and drug it. Now I could also right click on it and move the start and end point. So if I right clicked on it, I could move it 1 inch, and you see as soon as I put in 1, it moves the start point out. And I can move the end point 1 inch and redo my operation. Oops, went to the wrong side. So that's another way you can extend the tool path. Now you will see that as I'm cutting it, it's not wide enough to cut across the entire face of the part. So if I go back into my OpSim, and I have skip unselected ops, so it's pre-rendered everything and it's waiting to render that one. If I click, whoops, rewind. If I click start, you can see my passes are not wide enough to complete that entire step. This is where I can simply go into my process and add an extra offset. So I can add 1 offset. And what do I want my step over to be? So it's an 1.5 inch tool. So let's add, let's call it 1.125. Redo. Now I have a second step, which is going to be cut first. So if I go back into my OpSim, click rewind, and now play, it'll do 1 cut out here, and then it'll do a second cut here. So I can cut that entire ledge with 1 tool and 1 process, and it'll automatically offset that. So I've got my step cut here. So I'm going to clear on the right, deselect on the right, clear on the left. I'll make sure I do a save. Now I want to do a little deeper dive into my machining markers. So you saw I used them on my outer profile, and then I also used them on machining this step. So as I said, it's very easy to go in and make changes. So I'm going to actually go ahead and reawaken my finish pass, which is right here. So I'm going to double click that, and you can see it automatically applies the markers, it automatically shows the toolpath, and it wakes the process here up over on the left. Now I'm going to put my model in the body bag. So this is a body bag, and it's kind of like an alternate dimension. So if you don't want to see your models on the screen, you can just double click on it and it'll go into that body bag. So in looking at my top view, if I double click on that up, you can see my markers. And I can apply those markers anywhere on that geometry. Now there's a shortcut if I did want to center them by holding Control and clicking off in space. It'll automatically center the markers on whatever piece of geometry you've initially selected. So the way the markers work is, as I said, you have, I wanted the tool on the left side of the geometry, the center on center of the geometry, or on the right side of the geometry, and you can pick the direction you want your cutter to proceed. So left side and proceeding in this direction is climb milling around this part. Now the squares belong on geometry. That is telling the software what piece of geometry I want to start on and what piece of geometry I want to stop on. The squares belong on pieces of geometry. The circles, the black circle and the white circle, are extensions of the toolpath along that individual piece of geometry. So to demonstrate, let's say I only wanted to machine 3 sides of this part. Starting at the top, machining around this side and around the bottom. I could set my markers anywhere along this line. Then I could take the black marker, the black square, and drop the tip of that arrow on this piece of geometry down here. Now if I select the left side in this direction without doing anything else and click redo, you can see that I'm leading in up here, starting at wherever this marker is and coming around to the other side, feeding out, and then jumping up and over the part. Now that wouldn't be where I would want to start this. I would want to start it off of the end. So I would need to extend that toolpath along that piece of geometry. So again, the squares belong in the center of the geometry you want to start on. Now the white circle, I can extend that toolpath out this way. And the white circle and the black circle don't have to be on the geometry. They can be out in space, but they'll just extend that geometry. So I could drag this here and redo. And now my start point is way off here, and my end point is way off here. So again, the squares, white square is the geometry to start, black square is the geometry to stop. White circle is the extension of that toolpath. Black circle is the extension of the end toolpath. I could take this and drop it up here and redo. Not a problem. I could take this one and do the same. It just extends it along that line. Now I couldn't take it down here because it's not it's only extending that geometry that the white square is on. Now say I only wanted to do two sides, I would have to take my white square and drop it on, drop it on this line here. Then if I did a redo, it would start where this one is, and I could extend the toolpath up in this direction. So that's essentially how markers work. It says it dictates the start and stop point, start and stop geometry for the toolpath, and the circles extend the toolpath. Now with a closed shape, it's all going to start and stop at the same point by default. Again, holding control, clicking off in space will center it. You select the direction you want and the side that you want to start feeding on. So that's a deeper dive into using your machining markers. Now we've got our top step done and we talked a bit more about machining markers. I'm going to bring my part back out of the body bag by simply double clicking on it, and it brings it out into the screen. It's highlighted in yellow, so I do want to click off in space and deselect. And then we're going to go ahead and start machining this pocket with the island and this open pocket here. So I'm going to make sure I'm in my steps and pockets work group. I still have that piece of geometry. And I'm going to need the geometry for this rectangular pocket with the radiuses and this island here. So I'm going to go to face selection and select the bottom face of the pocket. If I right click on that and extract the edges, it gives me that geometry for the island and the pocket, and I'll turn off edge selection or face selection when I'm done. So I now have the 2D geometry for the island, deselect on the right, clear on the left, and for my pocket. So that's what I would need. Now, how do I determine what size tool that I can machine this pocket with? I need to know the size of these radiuses. So with the radiuses, if you have 2D geometry, you can go up here to your geometry palette and open that up. The dimension palette. And it will give you all these dimension tools to apply dimensions to 2D geometry. So if I wanted to pull the radius of that, I could simply select that radius, and I now have the radius, 270. So I know that I could probably go in there with a 1/2 inch end mill, walk that corner nicely, and leave a good surface finish in there. Now if this text is a bit small for you, you can right click on the top of your dimension palette and you can change the font. I typically change this to 18. You can change the font style if you'd like as well. That's fine with me. So I'll click OK, and then you see all of your dimensions get quite a bit bigger. I can use a horizontal linear dimension to select this point to this point. See, that's 2 inches. I could go from one side of this radius to another if I wanted that to see that dimension as well. So that's an easy way to figure out what size tool I can go in there and machine with. And to delete these, I just click on the extension line, click delete, click on the extension line, and click delete. You no longer need those. Now another way you can do it is by interrogating the model itself. So if I turned on face selection and selected this radius, if I went up here to plugins, I could go to solid inquiry. And if I click that, it gives me the minimum curvature radius of that radius. As a matter of fact, I can click on any radius and it'll give me the radius, and it'll give me the measurement of the radius. This one here. I could even go to these circles and click that, and it'll tell me the radius of that cylinder there. So this is a great tool that I use to interrogate my model instead of having to pull geometry, go to the dimension tab, and find a dimension for it. So this is another quick way. And again, that's in plugins, solid inquiry. So now creating my pocket, I'm going to do a smaller end mill. So I'm going to create a 3/8 inch diameter end mill. So I'm going to go to finish end mill, 375, 0 corner radius, 3/4 of an inch length of cut is fine, 3 inch overall length, that'll work. So I'm simply going to bring this tool down. Now remember, anytime you're roughing an area, which like a pocket is, you want to select the roughing tab. And I want to change my drop down. I'm no longer face milling. I want to use an offset cut. So I'm not going to worry about the cutting parameters. Again, your cut width typically defaults to the radius of the tool, half of the diameter of the tool. I'm going to put a small straight line and radius lead in. I'm a big fan of using 2 pieces of lead in and lead out, a straight line and a radius. That really helps if you're using cutter comp, because cutter comp typically, it always has to activate on the line, and it typically needs to fully activate on 2 pieces of geometry. So if you are using cutter comp, which I'm not, I like to have 2 pieces of geometry. So that's a great rule of thumb for me. Use line, 90-degree radius, and put a value in both of those. Because this is just a tutorial, I'm not going to leave any finished stock here. I don't need to use stock there, and I need to tell it, where's the top of my cut? Because we're not cutting from the top of the part, we've already machined this step, I'm going to use this and interrogate this top step. And then I'm going to interrogate the bottom of my pocket, and that tells it the bottom of the pocket, so I know that this is 200 thousandths deep. And that's fine. I'll put 0.1 in there, and I'll do this in 2 depths of cut. So when I'm machining a pocket, I want to select the outer geometry, and I can double click on that. And then I can double click on the island geometry. And you don't even need to do that. You can single select because it knows that that's a closed shape and then they're all connected. You can single click on one line of that. And if I click do it, there's my pocketing routine. And you can see the straight line radius lead in to each wall depth of cut to minimize a witness mark from tool deflection. And then you can even see it lead in and out of the island 2D toolpath. So there's my cut there. So if I want to run an OpSim on that, again, I'm using skip unselected op, so it's going to pre-render all the operations above it. And if I click play, let me slow it way down, you can see my tool roughing my pocket. Now we do have a great feature called volume mill, which gives you a tricoidal or dynamic milling or profit milling, whatever you want to call it, a high efficiency roughing toolpath. We're not really going to get into that right now. I'll do a couple more videos on volume milling later, but that's a great way to rough material out. This is really just kind of showing you the overview and the workflow for machining. So that's a good pocketing pass for right now. All right. Now we have another pocket up here. So I'm going to use the same tool to machine that pocket as well. Now I'm going to do it, pull the geometry the same way. I'm going to select the bottom of that pocket. I'm going to right click and extract those edges. Do it. Now you see it does create a closed shape, but in reality this is an open side to my pocket. So I'm going to use the same cutting parameters, same tool that I did to create this lower pocket, and without having to redo that process, I'm simply just going to go in here and change my depths. So I'm going to tell it that the top of this pocket is Z0 and the bottom of the pocket is here. I'm still going to do it in 100th thou depth of cut. Now if I click redo, it's going to change my lower pocket. I don't want to do that. I want to click do it. And that's going to create a new entire pocket. Oops, I forgot to select the geometry. Select that geometry tree and redo. So now you see I'm cutting my upper pocket. Now you'll notice it's not cutting outside that wall. And as a matter of fact, if I do a machine sim or OpSim, I can see it. It's pretending that that wall is not through. I'm going to change my visibility so you can see the edges of my model a little bit better. So that's not ideal. That's not what the feature actually is representing. I need to tell the software that this is an air wall. It's air, and so that the tool can violate that. So what I need to do is right-click on that line and change that feature to air. And you'll notice that the geometry is no longer blue, but it's red. So if I double-click that process and click redo, you can see now that it's approaching outside of that wall and feeding into the pocket. And it actually is trying to clean up that wall. Now, to control how much the tool does violate that air wall, I can go to open sides. And I'll typically put this as the diameter of the tool in my overhang. And if I redo, you can see now the tool nice and cleanly enters into the wall of the pocket and cleans that up. And it doesn't plunge down into the center of that pocket. So if I go back into OpSim, skip unselected ops, rewind, and play, I can now see I'm approaching outside that pocket and then feeding in and cleaning that up. So that's how you would approach an open pocket, or that doesn't have 4 closed sides. And I'm going to make sure I give it a nice save here. Moving on to the slot and the holes. So I have my pocket done. I'm going to deselect on the right, clear on the left, and I'm going to create another work group. So I'm going to go new work group, and I'll call this slot and holes. And I need to pull the geometry for these slots and the holes. Now, this leads me to something particular about this model. This is an imported step model. Now, occasionally, when a model is created in a different software, it has to go through a translation to import into GibbsCAM. I mean, we can directly import many versions of models, but say you import a model, and if you'll notice that all of my bores have a line going through them. And so if I were to turn on face selection and select that, you can see it's selecting these holes as half cylinders all the way down to the counterbore. That's showing me that there's the geometry didn't come in as clean as I would like from the other CAD system. So if I notice this, that if I were to extract the edges of these holes, it would come in as 2 half sections, which you wouldn't be able to drill. You can't drill an arc. It has to be a circle or a point. So that's not ideal. It just adds a little extra steps for us. So if I notice that a model comes in and it's not clean, you can see it's in the smaller holes as well, I can select that model, go up here to modify, and I can, to solids, and click remove unneeded topology. And you'll notice that it immediately cleans up those seams. And I typically run both of these tools, simplify as well, just to make sure it smooths out my model and removes any unnecessary vertices or surfaces. Now, it will not change your model dimensionally, so you don't have to worry about that. It just kind of cleans up the model. So for instance, if I now go into edge selection, select these circles, it will extract those. Turn on the edge selection. Select that, right click and extract the edges. They now come in as clean yellow circles. I don't have to worry about 2 half segments. I can turn edge selection back on, double click on the edge of my slot, extract those edges, do it. I could have used the profiler to do it. I just wanted to show you another different way of extracting edges. Now I have 2 holes on this angle here. Now, you have to be careful because you would not want to select the edge of this hole and extract it. Because if I did, it would not be a true circle. You see it does come in half sections, but one way to check the validity of 2D geometry is by using Control L. Control L turns on the internal label designations for all of the geometry on the screen. You see on the slide I have L1, L2, P5, P6, C. C's denote circles. That's good, clean geometry. Then you have lines and points. But if you see a B, that denotes a B-spline, which is a series of tiny, tiny line segments, and that's not something you want to machine. So you wouldn't pull the geometry from the edge of this hole because it's on an angled face, and it's actually, if you looked at it normally, it would be an oval or an ellipse shape. So I'm going to deselect that. I'm going to turn off my labels, Control L again. So for this, I would either want to use my profiler, where I would drag this so that I have a clean section of the hole, or I would just use edge selection and pull the bottom of the hole. So I'll use my profiler, select both of those, right click and extract the profile. Turn that off when I'm done using it. I strongly advise whenever you're using any of these tools which turn on and off different functionality, turn it on, use it, and turn it off. It will make your life a little bit easier, especially edge selection and the profiler. When you're done using them, turn them off. If you had edge selection on, the software may have problems discerning whether you're selecting 2D geometry or you're selecting the edge of the model. And plus, it makes your model look a little bit busy. So try to remember to turn those off when you're done using them. So again, I selected a cross section of the cylinder. They come in as nice clean circles, and I don't necessarily care where they are in Z, because as I said, the Z depths are going to be determined by your machining process and not where the geometry is. So I'm just going to leave those where they are. They're not bothering me. Now, I also need to determine what size tools I'm going to machine these features with. So that's again where I can turn on face selection, go into plugins, solid inquiry, and I can select the radiuses. So the end of my slot tells me it's 200. So I can probably go in there with, say, a 5/16 Endmill or a 1/4 inch Endmill, machine that nicely. These holes, 275 radius, which tells me that's a 550 through hole. And this is actually a counterbore. So I don't need this to be the same, this circle to be the same size as this, because I can drill on center of any circle or point. So that's fine for what I'm doing here. And then these smaller ones, 156.25, so that gives me a 5/16 hole through these parts. So I have the sizes of the tools that I need. Okay, so let's focus on the slot first. I'm going to create a 1/4 inch Endmill. Now, flute length. How do I know how long a tool I need to get through this part? Well, if I have my drawing, it'll tell me, but I could also just interrogate it. So I can go to, say, any of these tools that have a Z dimension, say force depth. I can double click in there and hold down Alt and select any one of the faces of the slot or the bottom of the slot, and it tells me where that number is, 0.85, and change. So I know I need a tool with at least 0.85 of flute length to be able to clean up this wall. So I can go into my tool, 1/4 inch tool. I'm going to give it a 1 inch length of flute, 3 inch overall is fine, 0 corner radius. So that's the tool I have for that. Now for these holes, it's a 550 hole diameter. So I'm going to create a drill. If I go to this, I can select it by number or gauge diameter, but I'm just going to put my own diameter at 0.550. That'd be the size of my drill. I think 0.551 might be the next normal size. Now the drill tip angle is important. Typically with a high-speed steel drill, you'd have a 118-degree drill tip angle. For a cobalt drill, it might be 135. Most carbide drills are going to be 140, so we're going to use a 140-degree drill tip angle. Now, if I don't know, most carbide drills, flute length comes in increments of the diameter. So typically they'll be 3 times D, 5 times D, 7 times D. That's 5 times the diameter. So if I don't know the actual length without looking in my tooling catalog, I can say 0.551 times 3 equals. That gives me the flute length that's or the actual drilling length that's 3 times the diameter. Now, say I had a metric drill. Say this drill was 14 millimeters. I could click I, simply hit I on the keyboard, and it'll give me the decimal equivalent of 14 millimeters. Or I could put in that number, 0.551, and hit M, and it'll give me the metric, the millimeter size in millimeters. So you can automatically convert any number in an input box from inch to metric. So again, I'm going to put in 14 millimeters, click I on my keyboard, and it automatically converts it to the metric size. So I'll use a 14 millimeter drill to drill this hole with a 3 times D flute length. All right. So I've got my end mill for my slot. I've got my drill for my holes. I'll use that same end mill to do this counterbore, and I just need a 5/16 drill for these holes. So again, GibbsCAM will do the math for you. So say you have a new guy out on the floor, a new girl on the floor, and they don't know their decimal equivalents. They could say 5/16 equals. And there's the decimal equivalent. So I'll take 0.3125 times 5 equals, and there's my flute length for a 5 times D 5/16 carbide end mill. All right, so I've got my 3 tools created. So I'm going to do my slot first. So I'm going to bring that tool down. That's going to be a contour. And I'm going to do a ramp down pass, kind of like we did when we were roughing the OD. So I'll leave a little bit of lead in and lead out. We'll see what that looks like. Get rid of our spring pass. Top of our cut is going to be Z0. Now where's the bottom of our cut? I had that number before. Let's say I forgot it. Hold down Alt and just select one of the faces of the slot. And it gives you the bottom extent of that surface, the face of that solid. So in this case, I'll just go minus another 25 thou to ensure that the corner of the tool breaks through the bottom of the slot. Equals. All right. I'll put a depth of cut in there. Let's call it 60 thousandths. I'm going to ramp down, turn off retracts. And I'll start at the center of the radius here. Now remember, when we apply our markers, if we want to center that on that piece of geometry, hold down Control, click off in space. Centers it. I want to be on the left side, my tool of the geometry, and I want to cut in this direction to climb mill. And let's do it, see what it looks like. All right. So I have a nice ramp down cut. Now if I look in for the top view, the lead in and lead out starts at the top, and on the bottom cut ends up down there, nice and clear. So I'm happy with that. I'm happy with that. All right. So once I'm done, deselect on the right, clear on the left. I'm going to go File, Save. Okay. So let's start drilling our large holes here. So I'm going to bring my 551 14 millimeter drill down, and I'm going to do a hole making process. So I'm going to select holes. Now you have a lot of different options on how you want to drill holes. This is where you would go to drill, to tap, to do gun drill, mill bores, all kinds of features like this. You can use your drop down. If I wanted to, say, do a G81 feed in, wrap it out, or a G82 feed in, feed out, if it were a reamer, I could select that here. You have different PEX cycles that you can select from. If you were using a tap, you have different tapping cycles, but I just want to do a standard G81 cycle, feed in, wrap it out. I put in my RPM here, let's say 3,500, maybe 15 inches a minute. You could dwell at the bottom if you'd like. And these are my clearance heights, 1/4 inch. We've stayed, that's still fine, not a problem. So this is the top of where I want to start drilling. Now you see this red line up here. It shows that some of these numbers are connected. So I do want to start drilling at Z0. Now I can tell it where I want the tip of the drill to drill to, or the corner of the drill. Where do I want the corner of the drill to end up? Now this is all based on your tool definition. So that's where you want to make sure you put in the right drill angle or spot drill angle or countersink angle, because the software will use that in its calculations. So for me, I don't care where the tip of the drill goes. I only care about where the corner of the drill. I want to make sure that the corner of the drill breaks through the bottom of this step down here. So what I'm going to do is highlight this, because this little line is pointing to the corner of the drill, and I'm going to interrogate this face of the cylinder. And that tells me that the bottom of the cylinder is 1.027 and change through the part. Now I want to make sure I break cleanly through the bottom, so I'm going to go an additional minus 0.05 equals. So now it'll automatically calculate where the drill tip is and the corner is. So I can select that hole. I can select this one. Now even though this hole is bigger, it doesn't care because it's going to drill on center. And I can select this circle. And if I click Do It, I have This red circle represents the tip of the drill. I have 3 holes going through center. Now you see the retract in between the holes is pretty substantial. So I can change that by using my transition between holes option to change it back to the R level. Redo. Now it just goes up to 1/4 inch above my part. So if I go to OpSim, I can see, rewind. There's my slot already, and I'll click play. And I can see my holes being drilled. Now, if I want to visually make sure that my holes are actually drilled through the bottom to this step, what I can do is I can superimpose my finished part onto my OpSim stock model. Now to do that, I want to select my model. Go into my OpSim. You can see it looks as it should. But if I change my stock to transparent by using these visibility options under here, the second one is turning stock to transparent. It turns the stock to transparent, but it also shows you your finished part. So if I slow this down and I click play, you can see it drills those holes, and you can see how far you've broken through the part graphically. So that's just one way to go back and visually check to make sure the corner of the drill is breaking through the bottom of the part. Same thing with the slot here. You can see that being machined as well. This will also show you whether you're gouging into your finished part, whether you're leaving too much stock, like we still have stock on our counterbore we need to machine off. We still need this bevel that we need to machine onto our part, and that our outer profile has cut past the bottom of the part. So that's a great tool to verify, validate the tool path that you generated with the finished part. So I'll turn that off. And now we just need to drill these smaller holes, these 5/16 holes. So what I can do is, I'm still going to use that same drilling process. I'll just drag my tool 8 down on top of it, and it now converts it to tool 8. Now it knows it's a 5/16 hole, so maybe I need to change my RPM a little bit. And I also want to make sure that I'm breaking through the bottom of this cylinder. So I'm going to go to the corner of the drill, interrogate the cylinder, it's a little bit deeper, and I'll go another -50 thou. I am going to be cutting from Z0, because remember, this angled material is still square, so I am starting at this Z0 there. And then I could just simply click do it, and I've got my next drilling cycle. Oops, I forgot to select the correct holes. I need to select these 2 holes. Redo. There you go. And again, if I go into my OpSim and run those, you can see where they're popping through the bottom of my part. All right, we're progressing. I'll hit deselect on the right, clear, file, save. Now we're into the home stretch with Op1 of this part. We just need to machine our counterbore on the center hole, and then machine this angle here, which is a 20-degree angle. So it's not a typical angle that you would be able to find a chamfer cutter for. So we're actually going to use a ball end mill and surface that. So to do our counterbore, we're going to stay in the same slots and holes work group. We have the geometry that we need, and let's use that 1/4 inch tool to machine that. So I'm going to take that 1/4 inch end mill, bring it down, and that's going to be cut with a profile, a contour. Now you could take a flat bottom counterbore and just drill that as a hole, but we're going to interpolate this cylinder. So I'm going to use a contour. I'm going to leave my lead in and lead out. We'll see what that looks like. I know I want to start cutting at Z0, the top of the part. Now I can interrogate this to tell me where the bottom of the counterbore is. So I can either select the wall, it's going to give me the lowest point, or I could select the actual face of the counterbore. It'll give me the same information. I'm going to give myself a 60 thou depth of cut. We're going to ramp down as well, and I just simply need to select that circle. If I want to center my markers, I'll hit Control, click off in space. It centers them up. I'm on the correct side, the left side, and I'm going in this direction, which is for climb milling. And I can click Do It. And there's my depth of cut for my counterbore. That looks good. I'm happy with the lead in and lead out. Let's give it a little bit more. So say when it's feeding down, it's hitting the edge of the material. Just for safety's margin, we can give ourselves, like, say 0.0 to 80. and we'll keep the radius the same. And that'll just extend it a little bit further to make sure that on my Z entrance feed, I'm not running the risk of hitting any of my counterbore material. So there's my counterbore. Now surfacing. We're going to use a ball end mill to surface this angled 20-degree angled face here. Now I don't need a new work group, but I am going to go to a different work group just because it makes all my geometry disappear, it cleans up my interface, and it's a little bit neater. So I'm on an empty work group, and I need to create a tool. So for this, let's create a 3/16 ball end mill. So I'm going to go to ball end mill, which shows it's going to have a full radius tip there. I'm going to call it 3/8 of an inch, 0.375, and I'm going to give it 3/4 inch length of cut. It doesn't need to be very long because we're going to be using the tip of the ball. Got the tool created. Now for this, I'm going to show you a simple way to do this, and then I'm going to show you a bit more of a detailed way, which involves a bit of solid modeling and a bit of model modification, which is going to give you a bit better tool path. So if I bring this tool down, and if you have the option for solid surfacer, that will enable you to use ball end mills to machine faces of your model. So I'm going to go in here to surface, and this is another step up option. So you may not have this available if you're on a very basic version of GibbsCAM. I'm going to bring up surfacing, and I'm going to give it a surface flow cut strategy. And we can dive more into this in another video. So I can give it my cutting parameters. And surface stock, this will tell me how much stock I want to leave on that face. And it's going to offset that face. So if I left 10th thou or 20th thou, it's going to leave it in an offset direction and not just straight up in Z. For this, I'm going to cut it right to Z0. This is my step over. And that'll be a bit more clear as I apply this toolpath. I'm going to give it 25 thou step over as we're going to step down the face of this to machine it. We're going to cut it in a back and forth direction, long edge, and top down passes. Now you'll see I don't necessarily need to worry about these too much because it's going to use the face of the model as its top and bottom cut. So if I just select the face of the model and click do it, you see it gives me a zigzagging depth of cut. I'll cut along short edge, and it'll just zigzag back and forth the face of this part. Now if I selected this one, you can see it wants to jump over that hole, even if I did long edge. So that's not bad. It'll give me what I want. So I'm going to hold down Control and select both of these faces, redo the operation, and I'll simulate those so you can see what that looks like. I'm going to turn off my transparency, rewind, and I'll hit play. Yep. Rewind, hit play. So there's my toolpath. It's going back and forth across that face, jumping up and over the holes. So it gives me what I want, and it'll be a perfectly fine toolpath, but it's giving me more code than I need. It's plunging up and down in the material, so it's not as clean as I would like. Same thing over here. So I'm going to deselect on the right, clear on the left. So with GibbsCAM, you can simply select the face of a model, and it'll give you the best toolpath it can. But if you create construction models and modify models, then you can possibly get cleaner toolpath, quicker cycle time, and less G code. So to do that, what I'm going to do is I'm going to take my model, put it in the body bag. I double-clicked on it, put it in the body bag. So I'm going to take that model now, highlight it while it's in the body bag, and I'm going to go to Modify and Duplicate. And I just created a second copy of that model. So this model that's back in the body bag, I'm going to rename it Original, or you can give it a part number, something that lets you know not to change that model, not to deviate. That's the original customer or engineering model. Now this model out here, I can do whatever I want with. So what I'm going to do is I'm going to close up these holes to give me a better surface for machining. Now to do that, I'm going to go into solid modeling, I'm going to open up my first 2 palettes here. Now I have 3 palettes that open. So I'll open up the first 2, and I take the solid one and I can just stick it to the bottom of this. And the third one and stick it to the bottom of this. And it's like a magnet, it connects it. So when I take all 3 of these and move them around, they all move together. So what I'm going to do is turn on face selection. So I'm going to select both of these faces. Now there's a tool down here called Unstitch Solid. Now if I select that and I deselect Create Plug, in general, 99% of the time you'll only have the 3 center boxes selected and unstitch. You don't want to create a plug, at least for this particular process. And click Do It. It will heal those holes out of my part. Now what I could also do is select, hold down Control, I'm on face selection, select all the faces of this pocket. And if I click Do It, it makes that pocket disappear. So now, if I reawaken that process, it's going to bring the one out of the body bag. So I have 2 models on top of each other. It's connected to this. When you create a 3D process on the face of a model, it connects those 2 together. So whenever you reawaken that operation, it's going to reconnect it to the face. So that's why it brought it out of the body bag. So I'm going to deselect that, put that one back in the body bag, and bring out our modified model. Now I can select that face and click Redo, and I have a much cleaner toolpath there. And it's still at an angle, so I can actually switch this to a lace cut. I'm going to say deselect those, and we can take a deeper dive into 3D surfacing, the solid surfacer module in later videos, and redo. I'm going to change the angle to 90 degrees. So I have a nice clean toolpath starting from the bottom and feeding up. So if I go into my OpSim and hit play, I get a faster cycle time because it doesn't have retracts and entrances. It's not jumping over these holes, so I don't have tool deflection. I have less G-code, and ideally a nice cleaner cycle time with less wear and tear on your machine. So that's the surfacing part of this block, and then we'll move on and we'll go to Op2. So moving on to Op2 for this part, I'm going to show you a method that you can use to quickly create second op stock and go from Op1 program directly to Op2 and try not to reinvent a lot of work. So the first thing I'm going to do is I'm going to go File, make sure it's saved. I'm going to Save As, and I'm going to save this as Op2. So this is essentially at this point a duplicate of Op1. So what I want to do is I want to run my full OpSim. Oops, deselect that, rewind and play. I want to run a full OpSim on my part, because what that'll enable me to do is if I right click on my OpSim rendering, I can create a facet body. Now what that will do is it will create a faceted solid model from what you see on the screen, my machined stock, which I can use to create stock for my second op. So if I click Create Facet Body, now when I turn this off, I'll bring it back out. You see I have a translucent faceted body which shows the cut part. Now this isn't a true solid model with all the functionality of these other solid models. It's essentially a point cloud of limited utility, but it does work really well as showing your stock for your second op. So once I have that, I can right click on this, tell it the body type is stock, and it'll turn blue. So if I now go into OpSim render, it shows me that facet body, and I can show my second op stock, my stock being rendered when I proceed with my second operation. So once I have that, I now can decide what I no longer need to move forward with my second op. So for me, all of my operations, I'll select one, hit Control A, it selects all my operations, and I'll delete all those. I no longer need these work groups, so I'll go through and delete those one at a time. I no longer even need the geometry for my work group 1. And then I'll put this in the body bag and I'll bring out my construction model, which I use to do the 3D surfacing. I no longer need that. So all I need is my original part and my facet body. So what I need to do is flip these over so I can orient them as I'm going to be machining my second op. So to do that, I deleted my construction coordinate systems earlier, so I do need to recreate at least one of them. So I need to go into and create a new coordinate system, and I need to create my YZ plane. So I'm going to go in here and relabel this YZ. I could have created all three of them, but for now I only need this one, I believe. So I'm going to select my stock model, go to Modify, 2D Rotate, and I can rotate this 180 degrees. Do it. All right. And I could have done them at the same time, but I wanted to show them to you separately. So I've got that rotated. It looks good. I'm going to rotate my part around 180 degrees. So now, if I go back into my XY plane and I do a shrink wrap, Modify Shrink Wrap, I've got my part shrink wrapped. Now, let's put my corner, or my work origin, back in my upper left corner of my finished part and at the top of the finished part. So I'm going to double click on my stock model, put that back in the body bag. And I need to move, like what we did with Op1, move my work part origin. So in X, I don't need to change X. It's on the end of the part, so I'm going to leave that 0. My Y, I want to move it up to this face of the part. And my Z, I want to put this at my finished face of the part. So I can click Do It. So now my origin's at the upper left corner of the part, at the top of the finished part. And my stock model's where I need it to be. So from here, I have all my tools already created. So any tools I need that I don't have in Op1, I could create down below. But for me, I think I have both tools to machine this part already created from my Op1 tool list. So that'll work fine. So let's go back and bring down our facing tool. So this is going to be a roughing operation. So I do not need a lead in. Oops, I need to change this down to face milling. Now for this one, it's a little bit different. It's asking for the top of my cut. Now this one has quite a bit more material than I did on the first part. So if I go into document control, I can see that I'm at 3242 for my stock top. Now in using a facet body, you can't interrogate this as well as you can an actual solid model. So let's see. Oh, it does give it to me. It does give me the top of my facet body. So that's the number I need. That's where the top of this cut's going to be. So if I put this away, I know I need to face this down to Z0, which is going to be the top of my part. So that's quite a bit to take off in one pass. So let's take this off at 80 thou depth of cut, 5 passes. So I'm going to use the stock and not a shape. So it has everything it needs. So if I click Do It, oops, I need to turn on my retracts. There's my spiral in roughing face pass. So if I turn on OpSim, like I said, you can see the part as it's been machined so far. And if I click, whoops, let me rewind. I can see my face passes. Oh. You see that red? That tells me something has collided. That's essentially a crash or where the tool is inadvertently wrapping into the stock. So that's a warning sign. And what that tells me is if I look at it, is one thing I didn't change is my clearance height. So my clearance height is lower than the top of my cut, so I know I need to increase this. So let's bump this up to 1/2 inch. Redo. So that should get rid of my part where my tool is rubbing on the stock or crashing. And you see those are the two 5/16 holes that I broke it into. All right, looks good so far. So I'm going to turn this off. I'm going to give myself a file, save, and then we'll go ahead and do the second 2 steps, which should be pretty straightforward. So I only need a couple of pieces of geometry. So I'm going to grab this geometry here and this geometry here. Right click, extract these edges. So I'll do the deeper one first. So just like I did on the top of my part on Op1, I'm going to use this 1.5 inch cutter, bring that down, and I'm going to do a contour. So I'm going to select this geometry, select to the left side. I'm going to put in a 1-inch straight line lead in because that will start my tool off the side of the part. Where's the top of my cut? Z0. Where's the bottom of my cut? Interrogate this face. 525. So let's give it, that's a bit aggressive. Let's give it a 0.15 depth of cut. I do not want to ramp down. And I'll do it. So if you look, the cutter does cut, that cutter will cut across the length of that, so I don't need an extra offset step there. So that one looks good, and we'll do the second cut. The top of this cut's at Z0, the bottom of this cut's right here. I'll leave it at 0.15, same lead in, and instead there's no redo. I'm going to select a new piece of geometry, put it on the correct side, and do that. So there's my next step to cut. So if I run these next cuts, there's the first step, there's the second step, it's broken into. And I think that finishes our part. So hopefully you've picked up a few tips and tricks and best practices along the way, and it was important to me to show you not just how, but the why you would do certain things the way they've done it. And I advise you to reach out to us if you have any questions, and we're going to try to include this model as a downloadable. So if you want to work along with this tutorial, hopefully be able to do that. So thanks a lot for watching.